there are many strange, unexplained things in outer space. For example, let's take Vega. Vega, also known as Alpha Lyrae, is a bright star located in the constellation Lyra. It's one of the brightest stars in the night sky and is easily visible to the naked eye from most parts of the world. Now, Vega may look like a beautiful, bright star to us Northern Hemisphere folks, but little do we know, it's hiding a secret. It's actually quite squashed. You see, Vega's high spin rate causes it to bulge at the equator, kind of like a cosmic belly. It rotates once every 12.5 hours, which is pretty fast for a star, and it throws material out around its waistline. It's almost like the star is hula hooping. This material is further from the center of the star, so it experiences less gravity, causing it to cool and darken, leading to a gravity darkening effect. So Vega is basically a cosmic fitness guru's worst nightmare. Although for us stargazers, it still looks round because we're looking at it from Earth's pole end. However, if we saw it from a different angle, we'd get a very different view. One that might make us wonder if Vega has been sneaking some cosmic donuts behind our backs. But while we might joke about its equatorial waistline, there's no denying that Vega is still one of the brightest and most fascinating stars in our galaxy. But if you want something actually bright, then how about a supernova? Supernovas are giant space booms that occur when stars reach the end of their life cycle. It's like the grand finale of a fireworks show, but on a cosmic scale. They release more energy in a few seconds than our sun will produce in its entire lifetime. And this is exactly what happened to the next star of our show. This celestial object with a weird name, IPFT 14HLS. But there's a catch. It isn't your average supernova. Even though this star made a blast in 2014 and started to fade away like usual, recently it made an unexpected comeback and brightened once more. Talk about a dramatic entrance. And if that wasn't enough, this thing continued to fade and brighten at least 5 times in total, which is a bit like a yo-yo. It's like the star just couldn't make up its mind about whether it wanted to stay bright or fade away into the abyss. Also, when scientists measured the supernova's spectrum, they found that it was evolving 10 times slower than other stars. Maybe it's a supernova that just wants to enjoy its golden years. All in all, this object is a real mystery. But this is not the only star suffering from the 2-in-1 syndrome. At first glance, MY Camelopardalis appears to be a fairly common star, but after a closer look, astronomers concluded it was actually 2 stars in one. These 2 stars are orbiting each other at over 600,000 miles per hour. It's a contact binary star system, which means that the stars are so close together that they share a common envelope. In other words, they're so close to each other that they're practically smooching. These celestial Romeo and Juliet are one of the most massive known binary stars out there. Each of them individually weighs in at a whopping 32 and 38 solar masses, respectively. Astronomers also think that they might be on the brink of a stellar merger, which means that one day they might just combine into one giant superstar. Wow, who knew space could be so romantic? Next, introducing another long name, HD 140283. Also known as Methuselah's star. This little guy in the constellation Libra has been around for a while, and by a while, I mean a really long time. Actually, scientists used to think it was older than the universe itself. Just imagine if it turned out to be true. But eventually, they figured out that it's actually around 14.8 billion years old, a peer of our universe. That's still pretty impressive though. This star is so old, it remembers when the Milky Way was just a baby galaxy. But despite all that, this star still has some life left in it. It's just starting to expand into a red giant, which is kind of like when you hit your 30s. Talk about aging well. But if all these things are somewhat comprehensible, then how about a star that was literally named WTF star by scientists? No, I'm not kidding. At least it used to be. Now it's called Tabby's star. It also has a more scientific name, but that one is a bit of a mouthful. But what's really bizarre about this star is its irregular dimming. For some reason, it doesn't glow like a normal star, but blinks, as if someone turned on and off a flashlight. And it's not just a little dip, we're talking up to a 22% drop in light. So it's not because it sometimes gets blocked by a planet or something. Scientists have come up with all sorts of explanations for this strange behavior, from comets to dust to even an extraterrestrial megastructure. That's right, but before your imagination runs too wild, it's important to note that the most likely explanation is just plain old dust. Perhaps the star is surrounded by some kind of dust cloud, and sometimes it prevents us from seeing it clearly. Although this explanation is still not 100% confirmed, there are still plenty of mysteries surrounding Tabby's star. One thing's for sure, it may be a bit of an oddball, but that's what makes it so fascinating. So, there you have it, folks. We're left in awe of the incredible diversity and strangeness of the cosmos. There's so much more to discover out there. So let's keep exploring and keep being amazed by the wonders of the universe.
Castles were cold places in times past. The stone seemed to radiate the winter chill. This is one practical reason why tapestries were hung upon castle walls, to help keep the cold out and the warmth in. But you just can't hang any old thing on castle walls. It should be beautiful, heroic, with a heavy wow factor. The ancient Greeks hung tapestries on the walls of their castle of the sky, glorious tapestries woven of stars. All 48 constellations of the Northern Hemisphere were designed and named by the Greeks. The story of Andromeda is one such tapestry, woven of 7 constellations spread across the entire autumn sky. The story contains detailed astronomical observations preserved as highlights in the sky tapestry. It begins with the constellation Cassiopeia, queen of the oldest realm in Africa, Ethiopia. When the constellation Cassiopeia is on the horizon, it looks like a staircase going up to the Milky Way. Step pyramids around the world are often thought to have been inspired by the constellation Cassiopeia. In any case, Cassiopeia is a beautiful constellation, indicating that Queen Cassiopeia was also a beautiful woman. She was good-looking, but equally vain, which sets off all the dramatic action. Cassiopeia can be found in the night sky opposite Ursa Major from the North Star. Like Ursa Major, Cassiopeia circles the North Star and is a circumpolar constellation. A supernova was observed in Cassiopeia around 1680 Earth time. Cassiopeia A having occurred about 11,000 years earlier. The Chandra X-ray satellite recently recorded an extraordinary photograph of this supernova remnant showing the elements sulfur, calcium, silicon, and iron amid the expanding cloud's high-intensity X-rays. Cassiopeia's husband is also a circumpolar constellation, a minor, dim one named Cepheus. He had his own kingdom. A merger of empires by way of marriage is something common throughout history. Cepheus was a king of Phoenicia. There were many kings of Phoenicia back in the days when Phoenicia was just a collection of city-states along the western shore of the Mediterranean Sea. Cepheus can be found in the area between Cassiopeia and the North Star. The constellation of Cepheus is important to astronomers. It's where Henrietta Swan-Leavitt discovered variable stars that pulsed at regular intervals. The rate of pulsation of the star indicates the true brightness of the star and enables a sure measurement of the distance to the star. The discovery of Cepheid variable stars was a major breakthrough for early 20th century astronomy. Cepheus and Cassiopeia had a daughter, Andromeda, also a noted beauty, about whom all the fuss is. It seems that one day Cassiopeia was boasting about the beauty of her and her daughter Andromeda. "We are more beautiful than any other women in the whole wide world." Well, such pretension can be forgiven for a queen. But then Cassiopeia went further and stepped beyond all natural bounds. In fact, "We are more beautiful than any of the Nereids." Well, the Nereids were Greek mythological sea nymphs, daughters of the ocean. Noted for their beauty and kindness to sailors, the Nereids, all 50 of them, took offense at being dissed by a mere mortal woman. Cassiopeia had to be punished for exceeding the bounds of the civil order. By her excessive vanity, Cassiopeia transgressed beyond the bounds of nature, for which an unnatural punishment was inflicted upon the entire kingdom of Ethiopia. A monster from the bottom of the ocean, the constellation Cetus, began to devastate the coastal villages of Ethiopia as well as Ethiopia's fishing ships. Fittingly, Cetus is a constellation of the southern celestial hemisphere. The fourth largest by area of all the constellations, Cetus swims in a dark part of the sky called the ocean, with only its head rising above the celestial equator. This part of the sky contains several water-themed constellations: Pisces, the fishes, Aquarius, the water-bearer, and Eridanus, the river. Over 50 exoplanets have been discovered in Cetus. You can bet the James Webb Space Telescope will have a field day analyzing the spectra of these planets' atmospheres, looking for signs of life. Meanwhile, Queen Cassiopeia and King Cepheus must do something about the monster devastating the shores of Ethiopia. They consult an oracle and make another trespass beyond the realm of reason and nature. "Tell us, oracle, what can we do to stop the monster from ravaging our kingdom?" This monster is not a normal affliction of nature. An offense was committed against the higher realms, and this is the punishment. The monster cannot be stopped by any normal means. Only a human sacrifice of the noblest being may placate the beast. One error compounds another. The noblest person in the kingdom, of course, is Princess Andromeda. According to the command of her father and the consent, or perhaps a suggestion of her mother, Andromeda is chained to a rock offshore. She is the human sacrifice that her parents hope will save the kingdom. Wow. Da-da-da-da! Here comes the Greek hero to save the day, stop the human sacrifice, and turn Cetus to stone. Perseus. Now, where is Perseus coming from? According to legend, the Hebrides. Perseus went to the Hebrides in pursuit of the Gorgon Medusa. The geological scope of this tapestry is incredible, from the Hebrides to the Red Sea. The Hebrides are an archipelago of mostly rocky islands off the western coast of Scotland. It was impossible to sail any further. The Hebrides were the absolute end of the world. Perseus didn't have to sail to the Hebrides. However, he flew on a pair of winged sandals. Hey, way to go, Perseus! Now, Medusa was one of the all-time baddies. One look at Medusa was so terrifying it would petrify you, literally turn you to stone. Perseus was in great danger. So, what did our hero do? Instead of looking at Medusa, Perseus used the scientific principle of reflection. He slew Medusa by seeing her reflected in his polished shield. In our sky tapestry, Perseus is portrayed holding up the severed head of Medusa. In the night sky, one eye in Medusa's head opens and closes and opens again. Arabic astronomers named the star Algol, the ghoul. Algol is an eclipsing double star. One star is bright, the other one, not that much. As the dimmer star orbits the bright star, it passes in front of the bright star, eclipsing it, and the eye closes. Since the dim star takes 2 days, 20 hours, and 49 minutes to orbit the bright star, the eye in Medusa's head opens every day and a half or so. The constellation of Perseus is immediately below Cassiopeia, and skywatchers quickly look to see if Algol is eclipsed, if Medusa's eye is open or closed. Perseus flew back from the Hebrides, accompanied by Pegasus, the winged horse. The central part of Pegasus is the Great Square, made up of 4 stars. As Earth goes around the Sun, the Great Square is right in the center of the night sky in autumn. In the summer triangle of Vega, Deneb, and Altair are in the middle of the night sky. In spring, it's Leo the lion, and in winter, it's Orion the hunter. These are the walls of the castle in the sky, and all have marvelous tapestries adorning them. The constellation of Andromeda shares a star named Alpheratz with Pegasus. It's one of the corners of the Great Square, so it appears Andromeda may be riding on Pegasus. Her crown, remember she is a princess, is floating nearby. M31, the Andromeda Galaxy. To see M31, cross the corners of the Great Square from the lowest star to the uppermost star, and then go a little further to see the Andromeda Galaxy. Be sure to peek at it from the corner of your eyes. It's called averted vision. The corners of your eyes are more sensitive to light, so you'll be able to see the huge spiral galaxy 2.5 million light-years away as a smudge of light 1.5 times wider than the full moon. Now, Perseus doesn't go in for human sacrifice, so he stops it and saves Andromeda by exposing Cetus to Medusa's gaze. And here we encounter the second eclipsing variable in our sky tapestry, Mira, the heart star of Cetus, the sea monster. Mira, from which we get the English word mirror, so fitting in a story about vain beauty, is an eclipsing double star. The dim star orbiting the bright star is a white dwarf, not bright enough to see with the unaided eye. The effect is that Cetus's heart shuts off. Mira is eclipsed and disappears. This cycle repeats itself every 332 days. Our fabulous star tapestry has the only 2 eclipsing binary stars visible to unaided eyes, the nearest spiral galaxy, and a hero that doesn't like human sacrifice and uses the scientific principle of reflection to thwart mythological monsters. Wow, I would hang that in my castle too. Just saying.
It was the year 2017 when astronomers spotted a bright star hurtling out of the Milky Way. It was moving incredibly fast at a speed of 2 million miles per hour. That's almost 4 times as fast as the Sun orbits around the center of our home Milky Way galaxy. It takes our star more than 225 million years to complete one journey. Anyway, back to our star, the Wanderer. The main issue with it was that it was moving against the direction in which most stars travel around the center of our galaxy. Even more bizarre, it consisted of totally different star stuff. Astronomers managed to identify its composition. The star was made up of heavy metallic atoms. At the same time, most of the other stars consist of way lighter elements. The wandering star got the name LP-40-365. It was moving so fast that it literally dashed out of our galaxy. This made scientists believe that the space traveler was pushed out of its place by some kind of cosmic disaster, like a supernova. A supernova is the largest explosion that can take place in space, an explosion of a star. It happens after irreversible changes start in the core of a star. Supernovas can occur in 2 ways, in binary star systems and when there's a single star. Binary stars are 2 stars orbiting around the same center. At some moment, one of the stars, a very dense white dwarf, starts stealing matter from its companion. After some time, this thief accumulates too much matter, which causes it to explode into a supernova. Or it can be a single star nearing the end of its life. It's running out of its fuel. More and more mass is flowing into the core of the star. In the end, the core becomes so heavy that it fails to withstand its own gravity. After the core collapses, a tremendous amount of energy is released in a supernova. But astronomers still can't figure out how a supernova could send LP-40-365 flying. There are more questions than answers. Was it a companion star that got flung out by a shockwave created by a supernova? Or was it a piece of the exploded star? A new study based on the collected data has shown that the star, which is a white dwarf, keeps slowly rotating around its axis. Astronomers are almost sure it means LP-40-365 is indeed just a chunk of space debris, and not a full-fledged star. This wandering piece somehow managed to survive one of the fiercest space events. But after making such a conclusion, scientists realize something amazing. LP-40-365's unusual features could appear after the star witnessed a supernova. Even though this event happened lightning fast, the entire makeup of the star got changed. Most stars consist mainly of helium and hydrogen. But LP-40-365 is different. It contains such heavy elements as magnesium, oxygen, and neon. It must have been the supernova that added these atoms to the star's composition. By the way, astronomers consider all elements that are heavier than helium to be metals. This means that after witnessing the supernova, LP-40-365 became metallic. Right now, the star doesn't have its own planets, but NASA's Transiting Exoplanet Survey satellite, which is on the lookout for distant planets passing in front of their host stars and dimming them, has noticed a curious thing. LP-40-365 brightens and then dims again every 8.9 hours. It might mean that the star pulsates, but usually stellar pulsations are much less regular. A more plausible explanation is that the star's surface is uneven, and as it spins, sunspots are brought into and out of view. And it's great news, because after astronomers figure out how fast the star rotates, they can understand what happened to it around 5 million years ago during the supernova. Bright blue exoplanet HD 189733b looks peaceful and eerily familiar. Doesn't it resemble Earth? But this appearance conceals the planet's terrifying nature. There, the winds blow at 5,400 miles per hour. It's 7 times the speed of sound. But that's not the worst. It rains glass, sideways, in this scorching hot world. Neutron stars are ultra-dense collapsed cores of giant stars. They emit X-rays or radio waves. But in 2018, astronomers discovered a weird stream of infrared light. It seemed to be coming from a neutron star 800 light-years away from our planet. The most plausible theory is that this signal was probably produced by a disk of dust surrounding the star, but there isn't enough evidence to confirm this idea. Mercury is the fastest planet in the solar system. It zips around the sun at a breakneck speed of more than 100,000 miles per hour. That's around 40,000 miles per hour faster than our home planet. It's one of the reasons why a year on Mercury equals 88 days on Earth. Mercury is the planet that orbits the closest to the Sun. That's why if you were standing on its surface at its closest approach to our star, the Sun would look more than 3 times as large as it does on Earth. The Black Widow pulsar is a rotating neutron star that is munching on its partner, which is a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. There's a stellar nursery in the constellation Centaurus, and even though this place is called a nursery, it's anything but peaceful or safe. It's made up of hydrogen and newborn stars and is located in a nebula around 6,500 light-years away from Earth. A nebula is a giant cloud of gas and dust floating in space. The intense energy baby stars emit makes hydrogen clouds glow ominous red. This energy is so powerful, it's eating away dark clouds of dust. Astronomers can see them disappear like lumps of butter on a hot frying pan. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice, and this ice is burning. The planet completes one full orbit around the red dwarf Gliese 436 in just 2 days. It means the exoplanet travels very close to its parent star. That might be the reason why the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet hosts huge volumes of water ice known as Ice X. And this ice remains solid despite such incredibly high temperatures. Jupiter is the largest planet in the solar system. It's 318 times as massive as Earth. It's also 2.5 times as massive as all other planets of the solar system combined. But here's a paradox. If this gas giant got even more massive, it actually becomes smaller. The added mass would make the planet denser, and this would cause it to start pulling in on itself. Astronomers claim that Jupiter can eventually end up being 4 times as massive as it is now. But at the same time, its size won't change. DGSAT-1 galaxy is as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thin. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind. Those are usually found in clusters. It can mean that DGSAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. Saturn's moon, Hyperion, is one of the most bizarre-looking moons in the solar system. But the appearance isn't the strangest thing about this space body. The pumice stone-like rock is pockmarked with countless craters, and it's also charged with static electricity, which is flowing out into space. About 4,000 light-years away from Earth, there's a planet that seems to be one enormous diamond. The planet is denser than any other discovered so far and consists mostly of carbon. It's so dense that astronomers think this carbon might be crystalline. It means that at least some part of the planet is diamond. Ceres is the most massive space body in the asteroid belt between Jupiter and Mars. It totals almost a third of the entire mass of the whole belt. But at the same time, Ceres is the tiniest of the dwarf planets out there. It's also the only dwarf planet that dwells in the asteroid belt, and also the only one that is located in the inner solar system. Astronomers sometimes call Jupiter a failed star. The gas giant indeed contains a lot of helium and hydrogen. But its mass isn't enough to start a fusion reaction in its core. And that's exactly how stars produce energy. They fuse the atoms of hydrogen together under extreme pressure and heat and create helium. In the process, they also release light and heat. Jupiter could start a nuclear reaction and become a star only if it was 70 times its current mass. Space is completely, eerily silent. That's because in the vacuum of space, there's no atmosphere, and the sound waves need some medium to travel through. That's why worlds with atmospheres like Earth are full of noise. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have enough mass of 1,000 sedans. One theory claims that tons of micro black holes could be created right after the Big Bang. Some scientists even go so far as to say that a couple of mini black holes pass through our planet every day. Every hour, the sun sends more energy to Earth than our planet uses in a year. Even though people are now using much more solar energy than a decade ago, it's still a mere 0.7% of the world's annual electricity usage. There might be moons orbiting other moons, but astronomers haven't agreed on this theory yet. Planets orbit stars, moons orbit planets. But why can't there be moons, also known as submoons, moonettes, and moons? Researchers claim that moons could exist, but the host moon has to be massive enough and the moon small enough. There must also be a large distance between these moons and the host planet. Jupiter is the most massive planet in the solar system. This means its gravity is also the most intense. It's 2.5 times as great as what we have on our home planet. Once, the gas giant's gravity even tore apart a large comet called Comet Shoemaker-Levy 9. Then the planet eagerly swallowed the chunks of the former comet. If you were standing at the equator on Mars, the temperature at your feet would feel like that of a warm spring day, but your head would be literally freezing. Lost in space and drifting through galaxies, rogue planets were once flung away from their parent stars, but one of them, floating 200 light-years away from Earth, is different from the rest. It's a planet-sized object with a magnetic field 200 times stronger than that of Jupiter. This field is so powerful that it generates never-ending flashing auroras in the planet's atmosphere. Europa is one of Jupiter's largest moons, even though it's smaller than Earth's moon. But the cool thing about this satellite of the gas giant is that it's covered with ice. And some of this ice is smooth, which means you could skate there. And a 3-foot axle jump you can perform on our planet would take you 22 feet into the air. At the same time, the landing speed on Europa would be the same as it is on Earth. Haumea, a dwarf planet orbiting the Kuiper Belt, has a bizarre elongated shape and 2 moons. The day on this planet lasts 4 hours, making it the fastest spinning large object in the solar system. But the most mysterious thing about Haumea is that the planet has a thin 40-mile-wide ring circling it. Astronomers haven't managed to figure out how or why it appeared around the dwarf planet. 11 Earths could fit across the equator of Jupiter, and if our planet was the size of a grape, the gas giant would be as large as a basketball. 9 spacecraft have already visited Jupiter. 7 of them just flew by, and 2 orbited the huge planet. The most recent of them, Juno, arrived at Jupiter in 2016. The craters of the Moon's south pole are likely to be the frostiest place in the whole solar system. The craters' floors are always in the shadow. That's why the temperature never rises above 397 degrees Fahrenheit, even during the day. If you decided to fly a plane to Pluto, your journey would take around 800 years. You'll find the highest mountain in the solar system on an asteroid called Vesta. Its peak rises 14 miles above the base of the mountain. This makes Rye Silvia, that's what the mountain is called, almost 3 times taller than Everest. Saturn's rings weren't discovered all at once. It happened gradually. That's why they were named alphabetically in the order scientists found them. Now they go like this: D, C, B, A, F, G, and E. A day on Venus is around 243 Earth days long, but the bad news is that you'd have to wait for a weekend for 3 years. All because a day on Venus is longer than its year. A solar phenomenon called terminator events is taking place at the Sun's equator. Disastrous magnetic field collisions seem to cause ginormous twin tsunamis of plasma. These tsunamis tear across the star's surface, moving at a speed of 1,000 feet per second. They can last for weeks at a time and happen almost every decade. The winds on Neptune are the fastest in our solar system. Most of them can reach the speed of 1,600 miles per hour. Almost any of these enormous storms could easily swallow our entire planet. The 18th brightest star in the night sky, Fomalhaut, is a terrifying sight. It's dubbed the Eye of Sauron because a ring of dust and debris circling it makes it look like a giant eye staring into your soul. The intimidating star is more than twice the mass of our Sun and is 25 light-years away from Earth, which isn't that far away considering distances in space. Mars has 2 moons, Phobos and Deimos. In the next 30 to 50 million years, the planet's gravitational forces will tear Phobos apart. It'll probably result in the formation of a ring around Mars. An asteroid the size of a car enters the atmosphere of our planet every year. Such an intruder could wipe out a small town off the face of the Earth. Dust and smoke would rise into the atmosphere, preventing sunlight from reaching the surface of the planet. It would cause the temperatures all over the world to drop and the climate would change. Luckily, such asteroids burn in the atmosphere before they even come close to the surface. The radio signal produced by a spacecraft when it contacts Earth is less powerful than a light bulb in your fridge. By the time this signal reaches our planet, its power is only 1/billionth of a watt. No wonder that antennas gathering these super weak signals are huge. The Deep Space Network that detects signals from spacecraft has dish antennas that measure up to 230 feet across. That's more than the width of a soccer field. In 1999, NASA lost a Mars orbiter because one engineering team was using the metric system, and another was doing calculations with the help of the imperial system. Nebulas are giant clouds of gas and dust. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger, and their gravity gets more powerful. One day, a nebula's mass becomes so great that it collapses under its own gravity and forms a new star. Around 4,000 light-years away, in the constellation of Scorpion, there is the Butterfly Nebula. Its wingspan is greater than 3 light-years, and the structure inside the nebula is one of the most complicated ever observed. The nebula's central star, a white dwarf, is heated to an insane 450,000 degrees Fahrenheit. This means it was formed from another huge star, likely more than 5 times the size of our Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. That's what probably makes the whole structure look like an hourglass, or a butterfly. If you decided to lump together all the known asteroids in the solar system, their total mass wouldn't exceed even 10% of the mass of our moon. A cloud of water vapor is floating in space. It surrounds a supermassive black hole 12 billion light-years away from Earth. The cloud contains 140 trillion times the entire volume of water on our planet. Astronomers think this water cloud appeared just 1.6 billion years later than the universe itself. The densest objects in space are neutron stars. They are the size of a small city, yet their mass is about 1.4 times the mass of our Sun. A single teaspoon of neutron star material would weigh 1 billion tons. And a neutron star's gravity is 2 billion times stronger than the gravity of our planet. In 1993, the Galileo probe was traveling past a miniature asteroid. It was no more than 20 miles across, and still, the tiny thing had a 1-mile wide moon. Astronomers have discovered tons of moons orbiting minor planets in the solar system since then. We live inside the Sun. The star's atmosphere stretches way beyond its visible surface, and our planet is well within its reach. That's how the gust of the solar wind creates such a breathtaking phenomenon as the northern and southern lights.